One more thing is that the study material what I have provided you is updated. It is not like other people that many recent RTPs are not there, MTPs are not there. Whatever I felt it is important, recent one has been put into the material. Means if you see, if you search, you will get recent RTP also. That is the October or November, whatever the institute has updated. That questions also you will get with solution or without solution. The solution so you can easily get once you know the source. So that is the thing. So no need to go here and there. Okay. Do MTP and all. Whatever the recent MTPs will be there, obviously, because I have given you the material for the next exam. Whatever the recently in the next 2 months it will be updated. That obviously you will have to go through it. But otherwise everything is updated. Okay. So let's start our class. I'm sorry, because of some technical problem I was not able to get connected, but from tomorrow I will be able to, I think. Okay, so I'll see to it that I get connected on time. So yesterday what we did was present value interest factor, correct? One more thing, if someone has felt that yesterday's class was difficult or you couldn't understand, okay, then that means you need a revision. I believe that if this is the exam papers difficulty, then obviously we should be at this level. Means our preparation should be at this level. If this is the exam level difficulty, our preparation should be at this level. So that is what I am aiming at. Okay. Yesterday I said about something about yield to maturity. Write one sentence about yield to maturity. Write one sentence about yield to maturity. Right? Yield to maturity is the return. Yield to maturity is the return. Yield to maturity is the return on the bond. On the bond. Yield to maturity is the return on the bond. If the investor holds the bond, if the investor holds the bond till maturity, if the investor holds the bond till maturity, if the investor holds the bond till maturity. A quick revision, quick recap, what we did yesterday. One was PVIF. What is PVIF? Present value interest factor. Very good. What is FVIF? Future value interest factor. Correct. To calculate present value, the formula was what? PV is equals to FV into 1 plus I raised to minus n. Minus n. Correct. If the power is negative, on our calculator, what we press? Divide. Counting will start from, we press divide. Counting will start from 1. For future value, what is the formula? PV into 1 plus I raised to n. If the power is positive, what we press? Into. The counting starts from 2. Correct? Okay. So these formulas will be applied for which cash flow? Multiple cash flow or single cash flow? Single cash flow. This will be applied for single cash flow. Graduates, when I say graduates, direct entry students, BCom, after BCom, please let me know whether you have a problem, guys. I hope it is not. Very good, great. Then what we did after this? Doubling period, right? Doubling period, right? Doubling period. I taught you 3 methods, correct? 3 methods. Please go through it. See, whatever yesterday, what I do, you know, generally what I do is whatever I teach na in the class, like YTM yesterday I introduced to you, but 2 to 3 times in the whole session, means in the whole course, okay, you will get it again and again. So it will be a revision for you, okay, but you should remember the thing. Okay, doubling period. After that, perpetuity, present value of perpetuity. What is the speciality about the, okay, what is the formula for present value of perpetuity? Installment upon interest rate. Very good, very good. You people are recollecting, that is a good sign. Now what is the speciality about this formula? Very good, it gives us value 1 year back from the date of first installment. So if let's say my annuity, sorry, not annuity, my perpetuity is starting from, let's say here, my annuity is starting from, perpetuity is starting from here, 10,000, 10,000, 10,000, like this, till what? Till infinity. Till what? Till infinity. When I apply this formula, which year value I will get? Fourth year. So is it present value? No, it is the value at the end of fourth year. So if I want present value, what I will have to do? I will have to pull this back for 4 years. Yes or no? By using single cash flow formula. One thing is that studying means studying for the sake of studying, and one is the grip what you have on the subject. Okay, and those who have the good grip, they will pass. That is for sure. Okay, let's move ahead. Write the heading annuity. Write the heading annuity. Write the heading annuity. Done. Listen. Write a sentence. What is annuity? Everybody knows it, right? What is annuity? Series of equivalent, equal cash flows, same cash flows, correct? Okay. So same cash flows for how many years? For a finite period, not for infinite, for a finite period, correct? So series of cash flow for a finite period, right? Even cash flows, write the definition. Even cash flow. Even cash flow. In bracket, write same. Write same. Even cash flow, same. For a finite period. For a finite period. At a regular interval. At a regular interval. Is called an annuity. Is called an annuity. Done. Okay. Listen. Now tell me 10,000, 10,000, 10,000, 10,000. Whether this is an annuity. Yes. Regular cash flow for an infinite period, not infinity, till fourth year end. So this will be called as annuity. Is this is an annuity? Is first and second will be annuity because they are regular, but third. In short, this is not an annuity. To be frank, it is not an annuity. Okay. The easier way to do this, we will learn that. Okay. Fine. Okay. So you have understood what is annuity. Okay. So take one question. Example. A person deposited a person deposited rupees 1 lakh. A person deposited rupees 1 lakh. A person deposited rupees 1 lakh each year each year for 4 years. each year for 4 years starting from the end of first year. Starting from the end of first year. Calculate the amount accumulated. Calculate the amount accumulated at the end of fourth year. At the end of fourth year, if interest rate is 9% per annum. If interest rate is 9% per annum. First, you should make a timeline. Okay. See, one way to solve the sums. Listen. This is the timeline. A person deposited rupees 1 lakh each year for 4 years, correct? Each year for 4 years. Starting from the end of the first year. Means 4 years you have deposited 1 lakh. Starting from the end of the first year. 1, 2, 3, 4. How much amount he will get? How much amount he will get at the end of the fourth year? That means here accumulated value. Correct? This is the timeline. So listen carefully. Here 1, 2, 3, 4. Cash flow 1 lakh, 1 lakh, 1 lakh, 1 lakh. Right? Obviously, see, think it is your money. You are going to get the money. You are depositing 1 lakh, 1 lakh, 1 lakh. For how many years? For 4 years. You will get the amount after at the end of fourth year. So can I say this will fetch a interest of 9% for 3 years? Do you agree? Everyone, if this is, yeah, this will get an interest of 9 years, single cash flow. So PV multiplied by 1.09 raised to 3. Correct? Anybody has a problem? Anybody has a problem? Are you understanding? If I multiply this, I should get the answer. Correct? That 1 lakh is deposited at 9%. Think of single cash flow formula. 1 lakh deposited at 9%. For how many years? 3 years interest he will get into 1.09. Here he will get interest for how many years? 2 years. 2 years, because 1, 2, 2 years you will get interest. At the fourth year and you are withdrawing the money. Think it is your money. Okay. Here you will get interest for how many years? 1 year. Here you will get interest for 0 years. Correct? Right? Your calculator. Take calculator. Anything raised to 0 is what? Anything raised to 0 is 1. Anything raised to 0 is 1. 1.09 raised to 1 is 1.09. On your calculator, 1.09 into equals to 1.09 into equals to 1.1881. Again equals to, don't press, again equals to 1.295. These are the factors. 295, 4 digits. 0. Okay. Fine. Now multiply this. When you multiply, you will get 1,29,500. I hope it is correct. I hope everybody is understanding what I have done. When I multiply this, it will be 1,18,810. If I multiply this, it will be 1 lakh into this factor, 1,09,000. If I multiply this, it will be 1 lakh. Right now, total of all this is how much? 4,57,210. Yes, 310. Okay, no problem. 310. Okay, 310. Correction. Fine. Intelligent people, tell me, this value is standing at which year end? At the end of fourth year. Very good. Some people now they think, see, this is first year, this is first year, so this is also standing at first year. No, you multiplied this with this factor, you took it 3 years ahead, so this value is at the end of fourth year. Understood? This value is standing at which year end? Fourth year end. This value is standing at which year end? Fourth year end. This value is standing at which year end? Fourth year end. This is the beauty of time value of money. Therefore, you could add it. And this principle, not in the syllabus, just for the sake of knowledge. This is called principle of additivity. What it is called? Principle of additivity. Why you can add it? See, CPT level CA foundation, teacher must not have told all these things. But if you want to learn something now, go deeper. This all cash flows are standing at the same point of time. First one, 1,29,500, fourth year end. 1,18,810, fourth year end. 1,09,000, fourth year end. Everything is standing at fourth year end. So we could add it. This is the time value of money teaches us. What time value of money teaches us? If the cash flows are at same point of time now, then only you can add. You can't add these things. Add in the sense, some people will say, sir, on calculator we can do now. I am not talking about that. See, think. Kilometer can't be added to liter. Kilometer can't be added to liter. Are you understanding? Same way, these are at different point of time. So I can't add 1 lakh plus 1 lakh. Because 1 lakh is at the end of first year. Second 1 lakh is at the end of second year. Third 1 lakh is at the end of third year. Different point of time. So I can't add it. Understood? Yes. Which one? End of fourth year. When 1 lakh was multiplied by 1.09 raised to 3, the value what you got, 1,29,500 is at which year end? Fourth year. Second one, when you 1 lakh, this one, when you multiply this 1 lakh with this factor, which year end value you will get? Fourth year. So you can add all standing at fourth year. Therefore, you can add this. You can't add this one. That is what I am saying. You can't add this one. Why you can't add? Because they are standing at different point of time. I hope the point is clear to everyone. Is it? Is it? Is it clear? Sure? Do you want me to explain again? See, listen. When this 1 lakh is standing at which year end? That 1 lakh is standing at which year end? First year end. So when I multiply with this factor, I am taking a future value for 3 years. So obviously from first year, when I take it 3 years ahead, this is the value standing at which year end? This is the value standing at which year end? Fourth year. Correct, na? This 1 lakh, this 1 lakh, this 1 lakh, when it was multiplied by this, this 1 lakh, when it was multiplied by this factor, this is 2 years ahead factor, na? So when 2 years ahead, from second year, 2 years ahead is what? Fourth year. So this is also at the end of fourth year. Yes or no? This is also at the end of fourth year. So because these cash flows are standing all at the end of fourth year, therefore you can add. Are you understanding? Because they are at the same point of time. That principle is called what? Principle of additivity. Principle of additivity. Just for the sake of knowledge. Why you can add this? If someone asks you, you should know this. In interview, if someone asks you, what is this? This is additivity. We can't add this. You can't add this according to time value of money. Understood? 1 lakh plus 1 lakh, calculator can do it. But logically, conceptually, you can't do it. Those who know the time value of money, they will not do it. Because they are standing at different point of time. Is it clear? Yes. Hmm. Yes, correct, na? Obviously, means who is depositing at the first year end, he will also get the same amount. What he's saying, if they are same, then why these amounts are different? Our amounts will be different, na? If you deposit at the end of first year, I deposit at the end of the second year. Otherwise, you think like this, you are the only one person, you are depositing some amount at the first year end, and you are depositing after 1 year, you will fetch the same amount on both the things. Think on this, how you can get, right, na? Okay, so is this clear? So, principle of additivity. So, this was a sum of annuity, correct? This was a sum of annuity. So, annuity sums can be done by formulas. Annuity sums can be done. This was logical. This was logical. Is it clear? This was logical, and annuity sums can be done by formula. So, there is FVIFA. FVIFA stands for future value interest factor for annuity. Okay. Now this was a sum of annuity and I have to calculate the future value. So I will apply the formula. What is the formula? 1 plus I raised to n minus 1 upon I. 1 plus I raised to n upon, this is the formula for FVIFA, future value interest factor for annuity. Understood? Exam wise, chapter is not going to come, but this things you can get in your questions. Is that clear? So you should know these things. Okay. Now here 1 plus, what was my interest rate? 9%. So I will take 0.09 raised to n is what? N is what? 4. What is the speciality about this formula? What is the speciality about this formula? What is the speciality about this formula? I couldn't get. What? It will be, it is a sum of FEF. Very good. Correct. It is a sum of the factors. Means what it is, what she is saying. It is the total of all these things. It is the total of this. These were FEIF factors. These are the sum of FEIF. Correct. No problem. The two speciality property about this formula is the n should be number of installment. First thing is what? N should be number of installment. Second thing, this formula gives us value on the date of last installment. Let us check whether we are getting 4,57,310. See, come on, give me the factor on your calculator. 1.09, power is positive, so I will press multiplication 2, 3, 4 and then minus 1. Divide by 0.09. The steps are on the screen. You have to follow this. 1.09 into, counting will start from equals to, counting will start from 2, 2, 3, 4 and then minus 1 divided by 0.09. 4.5731, that's it. Okay, now accumulated value is equals to annual cash flow, ACF, annual cash flow multiplied by FVIFA 9%, comma 4 years. So ACF was 1 lakh multiplied by FVIFA is 4.5731. Answer will be 4,57,310. Is it the same what we were getting? Yes, it is the same what we are getting. It was the same what we are getting. So no need to do this table. Is that clear? Directly you can apply the formula. Okay. Two properties. Property number 1. I don't know whether you people knew it or not. Property number 1 is always you should remember n will be number of installment. Is that clear? Property number 2, I will make you write, don't worry. Property number 2, this formula gives us value on the date of last installment. Okay, we will write this once you copy the sum. Any doubt till here? Okay, we have done it logically also, conceptually also, we have applied the formula also. Okay, so if anybody wants to understand this sum now, see, you are depositing 1 lakh for how many years? For 4 years. and you are getting that amount at the end of fourth year. That's it, simple. Okay, so how much you will get? Like this is the first year 2020 or 21, I will deposit 1 lakh. 2022 I will deposit again 1 lakh. 2023 I will deposit again 1 lakh. 2024 again I will deposit 1 lakh. At the end of 2024 I will get whatever is the accumulated amount, and that will be 4,57,310. Is that clear? Okay, please copy this. If you have done, please let me know. Always copy left to right. Left to right you should copy, because slide is going down. I hope the table is done. Done. Property number 1. Right, property number 1. In the above formula, n will be number of installment. N will be number of installment. N will be number of installment. Fine. Second, what I said? FVIFA gives us value on the date of last installment. FVIFA gives us value on the date of last installment. Property number 1, property number 2. Write one example. A person is ready to deposit. A person is ready to deposit rupees. Person is ready to deposit rupees 1,50,000 every year for 4 years, starting from the beginning of third year. Find the amount at the end of ninth year if interest rate is 9.5% per annum. If interest rate is 9.5% per annum. Try this. Give me the figure. Anybody with the answer? Okay. Okay. Okay, what is the answer? 11 lakh 42. 9 lakh 93 is one answer. Let us check. Okay, wait. Listen. Year cash flow 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what was the question? A person deposited how much? A person deposited 1 lakh 50,000. Third year beginning. Third year beginning means at the end of second year. So you should write here 1 lakh 50,000. See whether you have done a mistake. For how many years? For 4 years, correct? For 4 years. So understand, this is called compounding factor. What it is called? Compounding factor. Compounding factor at the rate 9.5. Now how much I said? 9.5. So this will get 1.095. 1.095 raised to how many years? Raised to how many years? 7 years, correct? Raised to how many years? 7 years. So this will get an interest for 7 years. Now those who have not understood, please listen. Those who have not done this. See, first year, second year, third year, fourth year, fifth year, sixth year, seventh year. Correct? So it will get an interest of 7 years. This will get an interest of 6 years. The next one will get an interest of 5 years. Next one will get an interest of 4 years. Okay. So can you give me the factors? 1.095. See what you should do. First you should calculate the below, the 4 one. How you will calculate that? 1.095 into 234. 1.095 into 234. Power is positive, so multiplication. Correct. Counting will start from 2. Answer is how much? Factor 437. Again equals to. The next step should be equals to. You will get the above factor. Tell me how much it is. 5742. Next one equals to again. Again equals to 1.7237. Okay, next equals to 1.8875. Okay, now multiply these things. Multiply these things. 1,50,000 into, someone multiply for second year, someone multiply for third year, someone multiply for fourth. Please do different calculations. First one, ready? Are you ready with the 130, 133? Okay, 133. Okay, it is 133. Fine. Next one. 569. Okay, next one. 550. Next one. Sorry, the third one. Okay, 2,15,649 he is getting. So it is, I think this is right. Okay. Check what you have made the mistake. I think is there any fourth digit here? Is there any fourth digit here? 1.437. What is the fourth digit? 6. Therefore she might be getting wrong. So now multiply 1,50,000. Hmm. No, multiply with only the 4 digits. Multiply only with the 4 digits. 125. If you multiply with 4 digits, okay, then you are getting 125. Okay, next 555. Okay, there is some difference. 555. That's fine. For 555. Okay, next 130. Next 640. Okay, if you're multiplying with this, see there will be some difference. Take the total. How much is the total? You just add this, na? You should use m plus. Add this, add this. Someone who have added this approximately 9,93. 450. Okay, fine. 450 is the answer, approx answer. So this is all. Therefore, they give you the factor. Listen carefully. Every subject has their own pronunciation. Every subject has their own language. Every subject has their own rules. Is that clear? In finance, listen carefully what I'm saying. In finance, actually our institute takes 4 digit. But what is the rule, you know? If this is 6 digit, na, if this is 6 digit, you should take here 6 digit to multiply. Are you understanding? That is the rule, basic rule, finance. Understood? But we are not following that. Institute, what they do, generally they do it, round it off at 4 digit. So we are taking 4 digit. We will match with the institute. Okay, fine. So costing people round it off at 4 digit. Costing people. Costing subjects gets rounded off at 4 digit. So you should know all these things. Okay, chalo. So 9,45,000. Now I will apply the same. I will do it by the way of formula. Okay, what was the formula? 1 plus r, so 1 plus I raised to n minus 1 upon I. So 1 plus 0. How much is the interest rate? 0.95. 1.095 raised to n will be number of installment. How much was the installment? How many installments you had? 4. How many installments you had? 4. 1,50,000, 1,50,000, 1,50,000. So 4 minus 1. Therefore, the 0.095, okay, is equals to, please give me the factor. Everybody should be comfortable with this. On your calculator, 1.095 into power is positive. So multiplication, counting will start from 2, 3, 4, minus 1, divide by 0.095. 4.6069. Now future value, accumulated value is equals to, accumulated value will be 1,50,000 multiplied by 4.6069. Please tell me how much it is. 9,93,000. No, there is some mistake. 1,50,000, 6,91. Okay. Right. Okay, correct. Yes, I missed some point. Oh, yes, that was a huge mistake. Okay, how much? 6,91,000. 35, 34. Okay, now listen. Therefore, you should know this rule. 34, 44. 44. Okay, 44 is the answer. Okay, we'll write 44. Now this, here comes the properties. You should know. N was number of installment. So I will get this value at the end of, on the date of last installment. My last installment was here, 5th. So this value is standing at the end of 5th year. This is standing at the end of 5th year. Okay, I have to take it how many years ahead? How many years ahead? 1, 2, 3, 4 years ahead. Correct? 5, 6, 7, 8, 9. 6, 7, 8, 9. 4 years ahead. So I will apply single cash flow formula. So PV FV is equals to PV into 1 plus I raised to n is equals to, okay, 6,91,044 is my present value for the time being, plus 0.095 raised to 4. Please give me the answer. 9 lakh. 1.095 into equals to 3 times 2, 3, 4. then multiply by 6,91,044. 487, approximately same, almost same. 487, 450, correct na? Almost same. So I have proved that in the formula. See, listen, why I gave you the properties and all. Listen carefully. Some people, they will take 7 years here in the formula. If you apply 7 na, that means you are assuming or you are taking 7 installments. Will your answer be correct? How many foundation people knew this? The formula is like this. How many foundation people knew this? That the formula is like this. Means it gives us value on the date of last installment. There what used to happen, there directly we used to get the questions. Correct na? Right. Ha. Say. Ha. Hmm. Uh, this, see, I am going logically. What you have learnt is formula based. Is that clear? So keep it aside. I will teach you the difference. Why it is not happening, I will teach you. But for the time being, have you learnt? What we have learnt is FVIFA. In FVIFA formula, N should be what? Number of installment. And it gives us value on the date of last installment here. Is that clear? Now those who have not done, please copy this. Those who have not done, please copy. I hope everybody is keeping pace with me. If you have not done, yeah, if you have not done, please let me know. Here you should write. end of fifth year, accumulated value, end of fifth year. Done. Shall we move? Okay. Now see what happened in foundation level. You used to get a very straightforward sum. So is to apply the formula. Okay. So here I am teaching you logically. So you can't means depend on formulas, because see, listen, I twisted the sum. I made it complicated. This is called annuity due, if I am not wrong. Correct? When the cash flow start from zero, it is called annuity due. Means now. Correct? So here straight away you can apply the formula. Okay, if you are applying, if you are going according to my logic now, if you are going according to my logic, you will apply means sorry, yeah, you will apply what? FVIFA. How many installments are there? 5. Correct now? N will be number of installments, and you will get the answer. And if you apply your formula, you should get the answer, whatever it is. Okay, so that doesn't make any difference. This is annuity due, just for the sake of knowledge. Someone asked me, so I shared it with you. When the cash flow start with first year now, that is like this, 1,50,000. It is called regular annuity. It is called what? Regular annuity. When it starts from zero, it is called annuity due. So anyways, it is not helpful for us anyways in further any of your calculations. You should know the logic, you should know the rules, you should know the properties, then you will be able to solve any type of sum. Okay. So next, right, present value, PVIFA heading, present value interest factor for annuity, present value interest factor for annuity. Write one question. Example. A person wants to receive rupees 1 lakh every year starting from the end of first year, starting from the end of first year for 4 years, for 4 years. How much? Full stop. And then how much he should deposit, how much you should deposit today if interest rate is 10% per annum? How much you should deposit today if interest rate is 10% per annum? If I make a timeline, say a person wants to receive 1 lakh every year, starting from the end of the first year. For how many years? For 4 years, correct? Okay, so timeline will be something like this. 1 lakh each year, starting from the end of the first year, for 4 years. 1, 2, 3, 4, correct? How much he should deposit? Is it a sum of annuity? Yes. Is it a sum of annuity? Yes. How much he should deposit today? That means it's a sum of present value interest factor annuity, correct? So present value they are asking. So here cash flow discounting factor at the rate 10%, present value. So see how I will do. 1, 2, 3, 4. Cash flow 1 lakh, 1 lakh, 1 lakh, and then 1 lakh, correct? So I have to pull this 1 lakh. How many years back? 1 year back. I have to pull this how many years back? 1 year back. So 1.1 raised to minus 1. Everyone, single cash flow formula. 1.1 raised to minus 1. This will be pulled how many years back? Second cash flow. Present value I want. So how many years back I should pull? 2 years. Are you understanding what I am doing? This will be pulled 1.1 raised to minus 3. 3 years. This will be pulled 4 years back. Correct? Give me the factor. How you will give the factor? 1.1 divide equals to power is negative. Divide equals to, tell me how much it is. 90. Again equals to, don't press anything. Again equals to 0.8264, 0.7513, 0.75 again equals to 0.7513, correct? Check. 0.6830, right? Now you have to multiply this. 1 lakh into this will be what? 90,090, correct? 900. 82,640, 75, 130. No need to multiply. Be smart. Be smart. Yeah, into 100, into 1 lakh, correct now? Factors will be multiplied. I hope everybody is understanding. Correct? Add this. Add all this. How much? 970. Okay. So this is the answer. Correct? Yes, anybody? Anybody? This cash flow is at which year end? Beginning of the fifth year means end of the 0th year. End of the 0th year. Don't talk in terms of beginning. End of the 0th year. This cash flow is standing at which year end? 0th year end. End of 0th year, because 2 years you pulled back. This cash flow is standing at which year end? 0th year end. Same. This also 0th year end. This all cash flows are standing at 0th year end. 0th year end. So we can add it. This principle is called principle of additivity. Principle of additivity. If the cash flows are at same point of time, then only you can add it. Okay. Okay. This cash flow, this is standing at which point of time? At 0th year, present value. You added the total of 0th year, so you will get the end of the 0th year. Correct? Is that clear? Now listen, no need to do sum like this. Because it's an annuity, you have the formula. You have the formula. PVIFA. Anybody with the formula? If you know the formula, please let me know. Do you remember? I will give you 1 plus I raised to n. Okay, minus 1 into 1 plus I raised to n. This was the formula given by your teacher. I will make it very simple. Don't use this formula. Do one thing, be careful, be with me. See, in your FVIFA, it was 1 plus I raised to n minus 1. Here what you do, 1 minus 1 plus I raised to minus n upon I. That's it. Is it clear? The initial part shifted to the right. Okay, this is from the derivation of that formula only, what you are saying. The big one. I into 1 plus I raised to n minus 1 upon I into 1 plus I raised to n. No need to use that. Okay, clear? Be with me. Please be with me. Listen carefully. Don't go ahead. Now here, listen. This is the formula. So how I will solve this? Listen carefully. How I will solve this? 1 minus 1.1 raised to n will be number of installment. How many installments I had? 4. So minus 4 upon 0.1. Is it clear, everyone? 4 installments I had. Interest rate was 10%. So 0.1. So 1 plus 0.1. Correct? Now those who are using the calculator, stop. First listen and then do it. First I will solve this part. Okay? First I will solve this part. Listen carefully. The power is negative. So 1.1 divide at your own speed. I don't know whose calculator. See, you are the best judge. You should know what you are doing. Okay. So 1.1. I will press divide. Counting will start from 1, 2, 3, 4. Correct. Okay. Then minus 1. Okay. Then minus 1 equals to. Then you should press plus minus sum. So that because it was. See, I took this. Then I deducted minus 1. So I will get negative. Right now. So to make it positive, I will press this button. Or else don't press that button, ignore the sign. That's it. Okay, minus sign. Ignore the minus sign. Everybody, divide by 0.1. What you are getting? 1.1. Follow this step on your calculator. 1.1 divide equals to 1, 2, 3, 4. Then minus 1 equals to plus minus. Plus minus means you know na, it's a single button on your calculator you have. Plus minus to make the numbers positive. Then divide by 0.1. What is the answer? 3.1698. Everybody, are you comfortable? Are you getting it? I want one person to say that I am not getting it. Who is that? Someone will be there who is not getting this figure. Everybody is getting it. Huh? Huh? I couldn't understand what you are saying. Huh? That is what we are doing. When you apply the formula, na, the formula is nothing but total of this. The formula is total of PVI factor. Now listen, how to take, listen, I have not finished the sum. Have you got this? Okay. Now the easiest way to do this sum, those who don't have the GT button, for them this is the step. Those who don't have the GT button, for them this is the step. Those who have the GT button, for them, listen, 1.1 divide equals to 1, 2, 3, 4 and then GT. Press. See, you will directly get the answer. That is what C is also saying. Yes. 1.1 divide by equals to. See, I will teach everything. Be patient. We will do everything. Be patient. Those who have GT button, please follow this step. Those who don't have GT button will have to follow the previous step. I will give you time to note. Is it clear? You are getting the same answer. Here also you are getting 3.1698 something. Correct? How I will calculate present value? Present value is equals to annual cash flow multiplied by PVIFA. So I am proceeding. What was the cash flow? 1 lakh, na? In the question? 1 lakh multiplied by 3.1698. So the answer comes to how much? 3,16,980. And in the table, how much we were getting? 3,16,970. That is more appropriate. Okay, not more appropriate. This one is more appropriate rather than that. Okay, that is approx answer because we have rounded it off at 4 digits. Okay, so formula will give you the exact answer. Is it clear? Okay, so this is how we should do. To property number one. Say property number one is what? N will be number of installment. Very good. In PVIF also N will be number of installment. Okay, fine. And second thing, one thing now, those who are thinking that array we learnt like this in CA foundation and we are unable to understand what sir is doing, or those who are facing a problem like that, you have to open up your mind. Please remember this. You have to be open to n number of ideas. If you're doing a professional exam, from here, there, from every corner, they will corner you. I'm telling you. And you have to be thorough with your knowledge. Is it clear? So PVIFA, I've just changed the formula, nothing else. What you have to do is the simple way. Those who have GT button, most of the people will have GT button. If you don't have, you should take a calculator which has a GT button. Remember this, because it will be helpful from here to the CA final. Okay, so 1.1 divide equals to 4 times and then GT. Okay, so this is the n will be number of installment. One more property. Come on, anybody? Second property, PVIFA. Exactly, it will give us value not on the zeroth. It will give us value 1 year back. 1 year back. It will give us value 1 year back from the date of first installment. Have we heard this sentence? Where? Where? Perpetuity. Very good. Perpetuity. Very good. I'm happy that you people are answering. Perpetuity. In perpetuity also the same rule was there. Here also the same rule is there. Is that clear? Okay. So you should know these things. Okay, please copy. Yes, say. We will get the value at the, I will explain it. You do it. I will explain it. You do this sum, copy this sum. He is asking me whether we will get the value of first installment. We will get the accumulated present value of all the installments. How the 1 lakh, only one installment's value can be 3 lakh? Apply some brain. Only single cash flow value, can it be 3 lakh 16,000? No, it can't be. All this 4 lakhs, present value is 3 lakh 16,970. I will briefly explain you on your calculator itself how the working is going to be done. Please copy this first. We will evaluate it. We will spend some time with the sum. Done. Please write this calci steps also. Please write this calci steps also. Okay, so that when you revise, you should come to know how we have done it. Done. Shall we proceed? N will be number of installment. N will be number of installment. Note number 2. Property number 2, what? PVIFA gives us value on the date of, sorry, gives us value, sorry, gives us value 1 year back. 1 year back from the date of first installment. From the date of first installment. From the date of first installment. PVFA gives us value 1 year back from the date of first installment.